Welcome back, everyone. In the last video, we implemented client prediction and reconciliation, which allows for a snappy controller while maintaining server authority. Today, we're going to focus on players with heavy lag issues during gameplay and how we can extrapolate their position based on their last known position and rigid body velocity. Finally, I'll show you a lot of mostly free tools that you can use to help build your multiplayer game. Hit that like button and let's get into it. I wanted to start today by showing some debugging that I put onto the player cart. Now it's just a canvas in a world space that has 4 text fields that I can push information onto from the cart controller itself. Now the reason for this is that very soon we're going to introduce an artificial latency in order to test extrapolation on the server side. The state on the client and the server, as soon as we have latency, is going to be different all the time. And the easiest way to see this is by throwing a canvas up into your game, whether it's world space like I have here or one that's a screen overlay that just shows you exactly what the server thinks is going on with your player and what the player itself is seeing in their own view. For me, I find that a little bit easier than reading debug logs, but we're going to get into that in a little bit too. So in our last video, we implemented client prediction and reconciliation for all the players when the player is the host, but we need to make a few more adjustments for when the client is not the host. And for the most part, all that really requires is changing where we're doing our checks for who's the owner, who's the server, etc. So let's take a look. First of all, let's remove this isOwner check in fixed update. In handle server tick and handle client tick, we'll do checks there instead. So in handle server tick, if we're not the server, just return. And in handle client tick, let's just add one more check here about the owner. So if we're not the client or we're not the owner, we're going to bail out. A few more changes here. We're not going to need to simulate movement on the server side anymore. We already have another method that creates a state payload, and that's the process movement method. So I'm just going to delete this method and replace the usage here. So we'll actually get a real state payload and not one created with simulated physics. Just above that, we have some redundant code that we're not using anymore. I'm going to clear that out. And I want to fix one more thing, and that is our latency factor. I was looking at this after the last video and I realized we already have a value that represents a fraction of a fixed delta time, and that is our timer's minimum time between ticks. So we can use that value to calculate our actual velocity per tick. So the last piece of the puzzle is going to be to introduce a cooldown timer. Now the reason that we need a cooldown timer here is because we don't want to get into a rubber band situation where the server and the client are constantly competing with each other and think that it has to reconcile every frame. In fact, it could be several frames. So for now, I'm going to use a fixed value for that. We could calculate it based on latency if necessary in a more complicated situation. Let's instantiate a new cooldown timer at that value. In the update method, we need to make it tick. And now, down in our should reconcile method, we can say as long as that timer's not running, we're okay to do a reconciliation. Then when we're handling the actual reconciliation, if we decide we have to reconcile, just kick the timer off. So let's jump back over to Unity. I just want to point out one more thing in the inspector, and that is I've increased the reconciliation threshold because we need to account for a little bit more latency. In the last video, we were just testing when the player was the host, and so it was very fast. We can have a little bit more grace here and adjust it as needed. Let's just start the build as the host, and in the inspector we can run as the client and just give it a try, make sure everything's working right. So I come down the track here and I try to teleport ahead. Yeah, the server reconciles me back to where I really should be. Now under the hood, there's just enough latency for that handle reconciliation method to actually run, but it's not going to do a reconciliation unless I'm actually beyond that threshold, like so. So that's enough about client-server prediction and reconciliation. Let's get into extrapolation. Let's take a quick look at the debugging that the network manager already has built into it. Now, as you can see here, we can set a millisecond delay that will let us simulate lag. Now I'm going to set my lag to 400 milliseconds, which is quite a bit. And you'll be able to see when we start playing from our little server cube and the client cube how much it's actually affecting the game. But in order to really start to deal with latency, we need a few more fields to pass back and forth. And the first and possibly most important one is we want a timestamp with every input that the client is sending to the server so that we can see how long it's actually taking. Along with that, I'm going to pass a little bit more information. I'm going to pass in the network object ID and a position. And of course, we need to serialize all that because we're implementing the iNetwork serializable interface and we want to get that information out. Down in the state payload, we don't necessarily need more information than that, but I'm going to pass around the network object ID because that I feel like that is the most useful identifier to be able to tell which object is which. So a little further down, we're actually creating instances of these payloads. So here's the input payload. So let's fill out those 3 new fields. We've got a timestamp, which we can set as date time now. We'll set our network object ID and the client's position. Now, if we scroll down a bit further to where we're creating a state payload, here we can fill in the network object ID using the static property, or we also have its value in the input. So I'm going to start my build as the host again, and then in the editor, we'll come in as the client. And just park this guy out of the way a little bit. And then we can just drive around the start area here. So if I come in like this, you'll notice right away, the red cube is the server. So on the client side, the messages coming from the server are quite lagged behind. And even if I come around, you can see that it's rotating properly. It's just, several frames behind us. If I stop and come back in, now I've moved the host up quite a ways up there so that we can kind of see in both views. But if I come up really here at top velocity, let's see exactly what the difference is. So that's quite far. But let's see what the host sees. Now the host sees the server is still a little bit behind where the client actually is. So essentially what we want to do is when one of the players is lagging so badly that there's that discrepancy between what's going on their screen and what's actually happening on the server, we need to make up that difference because they're probably having or starting to have a pretty major problem. Now, if they can overcome that and they start sending information again, we can just reconcile it. So Netcode for GameObjects actually has built-in extrapolation, but it only goes for 1 frame. What you just saw on the screen there, that's about 25 frames. Let's jump into code and see one way of resolving this issue. We're going to be adding one more timer. So I think what I'm going to do is rename this network timer to actually be called network timer just for clarity. We're also going to need a reference to our client network transform because we're going to be switching the authority mode on it. So let's come down into our netcode section where we've exposed some variables. I'll put 2 new ones here. One is going to be extrapolation limit. That's the threshold of what we want to handle as far as lag goes. Beyond a certain point, I think the player is just lost to us. I'm going to add a multiplier here as well because we might want to adjust just how much we're extrapolating based on our testing and whatnot. Now we need some private information, and one of them is going to be a state payload because we're going to decide what the next tick should be for this player, and we'll just put that into an extrapolation state. And we're going to have a cooldown because after a certain amount of extrapolating, it starts to get ridiculous, and either the player is about to DC or we're going to have to catch them up to where the server is. We'll have to make a decision beyond a certain point of time, and we'll just run a timer. When we start extrapolating, we run the timer, and when it runs out, we got to handle it. So let's get some values into all those variables. So we've got to fetch our client network transform, and then let's handle our timer. The cooldown can just go run off the extrapolation limit. I think that's good enough. And we've got some methods that we can hook into on our timer class. So when the timer starts, what we want to do is switch the authority mode because as far as the server is concerned, the player is not sending us input anymore. And until they do again, we're going to run it in server authority mode. And that means we're going to stop syncing all of our positions just temporarily while this thing is running. So we'll turn all of those off. Likewise, when the timer ends, Copilot's doesn't quite have the names right. It was a good guess. On timer stop, we want to do the opposite. But we also want to empty out our extrapolation state just so that there's nothing there. Now, obviously we have a bunch of duplicate code here, so let's extract a method. So this is more or less what I want, but let's change the method signature to accept an authority mode as a parameter. And that way we can pass in authority mode server when the timer starts, and we can replace all this code on the timer stop to actually pass in the client authority mode. And then in the method, we can just say authority mode equals mode. And we can also just create a little Boolean here that says, as long as we're in authority mode client, we should be doing a sync. One more thing to do with our timer here, and that is every update, we need to make it tick. So let's just add one more line down here in the update method. All right, that's all of our setup done. Now we just need to write some methods that'll handle all this. I think the first thing that we should do is create a static method that will just calculate our latency for us. And it'll be very simple. We can just subtract the current time from whatever time was on the timestamp and get the milliseconds from that. Now, when this milliseconds property actually returns a decimal value at like a representation in seconds. So what we'll do is just divide it by 1,000 so that we always have millis. Now let's jump up into handle server tick. I'm going to move this declaration for input payload outside of the while loop because I want to use the very last input payload that we process into the calculating the latency. This way, outside of the loop, we'll have it at the end of our method here, and we can do a handle extrapolation. We'll get the last state out of the buffer, and we'll also pass in our latency value calculated off of the input payload. I'll declare a new method. So in our new method, the first thing we should do is a check of whether or not we should actually be calculating some extrapolated values. If our latency is less than our limit, and it's greater than one fixed delta time, which we know is already being handled by Unity, then let's start worrying about it. Let's figure out first how much rotation is going on. We'll get an axis length. To calculate that, we'll just get the magnitude of the angular velocity into degrees, and then we can calculate an actual quaternion out of that. Let's also say that if we've already extrapolated a state before and we have values in there, let's actually set our latest to be whatever we've been calculating off of. Our extrapolation state can simply build off of itself. Then we can figure out exactly how much we want to move, which is just a calculation of the latest velocity plus, taking into account our multiplier and the latency. Then we can set our rotation, our velocity, our angular velocity. Then we can start our extrapolation cooldown timer. If the condition failed and we didn't execute that block of code, then we're actually within a reasonable amount of latency and we want to stop the extrapolation cooldown because at that point, the player should be back in control. We already have some code that'll handle reconciliation of the difference between the server and the client, but you could add something a little more gentle here if you wanted. The last thing to do with this method is I think I'm just going to pull out this if condition into its own little expression body method so it's a little bit easier to read. So now we know based on latency how much we want to actually move the cart ahead, but we need a method that will actually apply this change to the cart on the server. So let's make one more method. Let's call it extrapolate. So whenever we call extrapolate, as long as we're on the server and we should be extrapolating, that is the extrapolation timer is running. Now I can see I can't find it on the list here because I have a typo in it. I'll fix that in 1 second. So as long as it's running, let's start by just changing the transform. So the transform of the cart is going to increase by whatever amount we set into the extrapolation state position with a y value of 0 because we don't really want to multiplying gravity on us or anything weird like that. Depending on what you're doing, you can either extrapolate in the update method or you can extrapolate in the fixed update method. Now I'm going to put it here, just make entries for both because it really depends what's happening, with other systems trying to affect you. For example, in a network game, our network transform actually doesn't have a fixed update method. It only has an update method. In fact, let's go look at it quickly. If you're in Rider or other IntelliJ products, if you hit Shift, that'll allow you to search anywhere. So let's find network transform in the Unity library and open that file up. Now, if I search for fixed update in here, you'll see there is no results. However, update, or actually maybe void update would be a better one. Here we go, protected virtual void update. So this is an overridable method, and you'll notice here there are some very interesting comments. So I think it's worth digging into these things once in a while, because you're going to find little bits that you're not going to see in the documentation for sure, such as this comment to do. They're changing how much non-authority clients can lag before they'd take action, not unlike what we're doing in our system. I'll just use Shift again. If we jump over to the client network transform that we've made, this one inherits from network transform. So there may be situations where you want to start overriding it here in this class. Okay, let's come off of that little tangent. There's just one more thing we have to implement in our code here, and that's we don't want it reconciling and extrapolating at the same time. So in the extrapolation timer, when it starts, make sure the other one stops and vice versa. And let's also come down to our check whether or not we should actually start a reconciliation. Let's just make sure we're not actually in the middle of extrapolating data. So with that underway, why don't we give it a shot? Now I'm going to start my build as the host just so we can watch on the little screen and see what's going on. So I'll just pull him over a little bit. This client is going to lag out all the time. So it's going to extrapolate the position every frame. And all we have to do is give it a little push here and it'll start moving by itself because it thinks we're not getting any input. So I'm just going to base my next position on what it was before and so on. Now the player can keep driving. To the player, they won't know the difference, but on the server side, they're actually going to see the cart where the red cube is. So as you can see here, it just keeps moving along and the cart visual is there while the client is just standing still, right? Now, at a certain threshold, he's going to be out of range such that it's going to make it force a reconciliation. But I would say it's probably in our best interest at that point to just consider that player disconnected, because that means they've been, over 4 seconds since they've sent any input to the server at all, which is, it's not even worth playing the game at that point if your connection is that bad. I'm going to make a couple builds and tweak these settings a little bit so that I feel like the extrapolation is moving at a decent rate. While I do that, though, I wanted to suggest an alternative. If the cart was out of touch for a few seconds, we already have an AI driver. Technically, you could just drop in the AI driver for the player's input temporarily until they've start sending packets to the server again. But anyway, you're going to have to spend a lot of time tweaking settings in a multiplayer game. In fact, I would suggest you probably spend more time finessing this kind of thing than you would on actually writing code. And to do that, you're going to have to make a lot of builds, or I would like to show you guys a tool that will save you a lot of grief. So while I was working on this episode, I used this tool here. It's an open source library called ParallSync. What it does is clones your instance of the Unity editor by making symbolic links to important folders, and it only copies the things that it absolutely has to. And that way you can have 2 Unity editors open at the same time without having to make builds. You can connect 1 or more clones to your multiplayer game and test everything out. It's super simple to use. The only thing I would say about it is that it does use a lot of resources. So the clones I'll use, it seems like just about as much memory as the original. I'll just put a screenshot of what my desktop looked like when I was working on it, so you can kind of get an idea of how it might benefit you if you want to use it. But I'll put a link to this in the description. I'm just going to show 2 more tools. This first one is a fairly powerful open source command console that you can just drop in and have into your build so you can see output and run commands. The other is a little bit simpler, but it just shows all of your debug logs entries. So it can be very helpful when debugging if you don't have a paid tool that does this. And finally, I do want to show one paid tool because you might already own this. This was in the Lunar bundle this year, which came out just after Christmas, and it's called SmoothSync. And it's basically does kind of what we're doing, but in a much more powerful and robust way. And it comes with all the source code too. So if you're really interested, you can dig right into it. It's very well commented. It's basically a drag and drop solution that handles syncing all the rigid bodies in your game. Now, before we wrap up, I just want to remind everyone not to forget to turn the lag settings on the network manager down to 0 again when you get sick of optimizing your game for latency, as trying to fix networking issues gets tiresome after a while and certainly frustrating. If you want to turn off extrapolation for any reason, don't forget that if you set the timer to 0, that effectively turns it off. So this is the last episode we'll be talking about lag. Next episode, we'll get more into the final aspects of gameplay. Hit that like button and subscribe to stay up with more content like this. Thanks for watching, and I'll see you in the comments below.